So hello guys, today we will be solving this question, that is remove init node from the end of the linked list. Alright, so this is the most basic question that anyone will solve. In spite of this fact, Leetcode has tagged it medium. Alright, Leetcode for the win. Alright, so this is the basic question that one should solve if he is starting from the linked list, because it will like strong your basics, of course. So we are given the head of a linked list and we have to remove the nth node from the end of the linked list. All right. Then remove the nth node from the end of the linked list. This is a singly linked list, guys. So there's no way that you can traverse it from the back and remove the element because it's not doubly linked list. All right. Now return its head. All right. We have to return the head as every function of a linked list works. All right. So there are two things in this question, and the question is done. The question is killed because it's no more a question. It was. All right. So there are two things. Let's discuss it. So the first thing that we will have to see is when I say you that understand the first point. All right. So when I say you that this is the first node, this is the second node, this is the third node, this is the fourth node, and this is the fifth node. From the front, this is the way we go. And from the back, this is the first node, this is the second node, this is the third node, this is the fourth node, and this is the fifth node. All right. So this is how it works, right? Now, when I say that this is what we have given, that the nth is from the back, from back. Now, if I get somehow that lth is from front, it would be very easy for me because I can just traverse and get the value from front. Then I will just traverse the linked list, and whenever the point comes, that is the lth point, I will just remove that part. That is, we know very well. That is the basic part. Now for getting lth, we know in maths we have studied in our 11th and 12th class that anything from the back, like this is the nth from the back. So from the front it will be nth, that is size, first of all, size minus nth plus 1. Let's try it out. Let's say we take this. All right, I'm taking this part 2. From the second from the back will be size is 5 here, nth, which is second from the back, plus 1, which will give me 5 minus 2, which is 3 plus 1, which is equal to 4. So the fourth node from the front is the second node from the back. And we can see it is right. Let's discuss about the first node from the front. All right. So first node from the front can be written as nth plus 1. So first from the front is equal to 5 minus nth plus 1. So this comes out to be 5 is equal to n. So first from the front is last from the back. Yep, correct. So our formula is right. So first point that we have to remember in this question, first point of solving this question, that is from the front, let's say f is equal to size minus nth plus 1. This is the basic thing that we will use. Now the second thing that I need to focus on this question is, if we see for removing the fourth node, I have to remove the third node. I have to go to the third node. I don't have to remove the third node. I have to go to the third node. Then I have to delink it and link it to this node. So what we are doing, it was linked like this. All right. So basically it was linked like this. But now I have to link it like this. It was linked like this, but I now have to link it like this directly. So we will skip this one basically. So how we will do that? Let me make a block for it. Let's say this is, and I would now I'm considering from the front. Okay, so this is f minus 1, that is f minus 1 node. This is fth node, that is we have to remove from the front, and this is after the f plus 1 node. It can be anything, we don't care about it really. All right, so this is the visualization that I would like to represent to you all. So this is data, this is data, and this is data. All right. And next, next. All right. So it will be connected like this will be pointing to this. In Java, we don't have pointers, we have reference variable. You may know that. So reference variables are the variables that point towards an object, and we know our node is an object of the like node class, which is defined here in the question answer. Yeah. So yeah, there is our link list node class of which our node is a object. All right. Coming back to the question. All right. So this next will point to this. Now I have to skip this. So my f minus 1 dot next should be equal to my fth dot next. Is this making sense? Yep, it's making absolute sense. Because now my this next fth dot next is this, right? Fth dot next is this, right? So now what I am doing, I am pointing this next directly over here. That's what I needed. That is what I wanted to do. I want to skip. Now this is skipped. So that is what I needed to do, and I have done that. And now, of course, garbage collector will remove this. So we don't need to take care about this. This is not see that we have to break our heads for removing this, that our space get free. Java garbage collector will automatically free this space because there is no part to go to this node anymore. All right. So if I write my pseudocode, it will be somehow. First, I need to find my size. All right. Then I need to this is the algorithm. First, I will need to calculate my size. Then I will need to calculate fth node, that is which node it is. All right. After that, I will go to my f minus 1th node, and I will delink it from delink from f fifth and link it to f plus 1. So these are the four basic steps that we need to do. First, second, third, and fourth. All right. So these are the four steps that we need to do. So let's do it. Let's write the code then. I'm not that much good in writing the code, so please bear with me if I get stuck in the middle. All right. So this is our coding right now. Let's reset this. All right. Coming to the point. Right. First, I need to calculate my size. All right. Let's calculate the size here. So public static int type and sizes. Function v sizes, and we will pass the head list node, right? Yeah. All right. Now for the size, let's declare a variable in size equal to 0. Now for the temporary node, I will declare, we know, right? This is very basic for us. We declare a variable size equal to 0. For initially our size is 0. Then we will declare a variable temp because we don't want to change our linked list. We only want to traverse this. If I move my head, my linked list would be changes with I do not want. So I will create a temporary variable of list node data type. All right, which will handle the traversing. So that my original linked list remain as it is. My head is where I wanted and my tail is where I wanted. All right. Now I will make this move till my temp is not equal to null. All right. And I will increase the size every time, and I will move my temp forward every time. All right. Once this is done, I will return size. All right. Absolutely fine function. Now, if you say you can say that I missed the edge case. No, I didn't. See, if my head is null, this will become true and 0 will be returned. All right, so I didn't miss anything. This is the small basic function for the size. All right, coming back. And if you're writing on VS Code, if you're declaring all the functions, you can just declare the size variable as a static variable over here, and you can just like over here I write static public static, then integer of course, then size, and then update it like whenever you add plus plus. On adding we do plus plus. On subtracting, we do minus minus, and my size will be maintained. And I can get the size in big O of 1 time complexity, not big O of n like here. All right. Now moving forward. All right. Now I need to calculate my effort node, right? What is my effort node? I have calculated my size. Now let's come into effort node. So int f is equal to, what was the formula? The formula was size of my linked list minus my init node, which is given to me plus 1. So this is the node which I need to do. All right, great work. Now I will traverse. For traversing again temp, I told you the reason why, because I don't want to disturb my current linked list. All right, while my I will also take a pointer variable that I will move. If my I is not equal to, I would take I is equal to 1, because we are doing it 1 based indexing. If I is not equal to f minus 1, we will keep moving. Alright. And I will increase my I every time. Also, as well as I will increase my temp. Temp equal to temp dot next. Alright. Now, once it's done, now I need to delink and link. Alright. So which part I am talking about? We have calculated the size, we have calculated the f at node. Now we will go to the f minus 1 node. Yes, we have done it. We have went to it by the temp variable by traversing. Now I need to delink from the effort and link to the f plus 1. Alright, coming back to the code. Alright, let's do this. So it can be written as my temp dot next is equal to the effort node which is there. So this is temp dot next dot next. So what did I do just now? So I just skipped that. If you can see, coming back to the code, if you can see here, 1 second please. Yeah. So if you can see here in the code, see, if I have this first, second, and third, right? We have this. Please ignore the sizes and the shapes. All right. If this is my temp, this is my temp dot next. Makes sense? Now this is my temp dot next, right? So I directly moved it here, skipping it. All right. So this was the thing that I did in the code. Hope you understand it. All right. Now I can return my text, and it should work if I am correct. Compiler. All right. Here we have head. One time error temp is dot next. Okay. So here we have encountered the error. Why it is so? Because if my head is null, what we will do? Now, an important point we have to discuss here is the edge case. All right, coming to the edge case. All right, so guys, coming to the edge case. What is the edge case? If there is an error and you forget, that will make a big impact on your brain. If I write it exactly once that this is the edge case, it won't make impact. All right. So if I have to remove, there is only one. Suppose if I have to remove the first node, suppose I have this element. All right. This is my head. This is pointing towards null, and my null points nowhere, of course. Now, whenever my head becomes like this, if you can see, it is pointing null. This is temp. This is temp dot next, and there is nothing such as temp dot next dot next. There's nothing like that. So it is giving me error. What should I do now? To overcome this, I will do one thing. That is, whenever my head is there, whenever my head is there, I will just return head dot next. So if my n is double equal to, I would write it, if my f double equal to 1, then I will return head dot next. Simply. Now it should work. Yep. So whenever my head is involved in it, I will return head dot next so that it doesn't make nuisance. All right. So this was the edge case here. Edge case for this. All right. Now let's submit it. All right. So here we have done this question successful. So this was how this question was solved. So if I felt like that I should explain the edge case more in this question. So coming here, if we can see, this is our edge case which I write. Coming to the this. All right. Now my edge case was my edge case is that if my f is 1, that is my head variable. All right. I will return head dot next. All right. Now coming to explanation of this. See, if I didn't wrote this, what will happen? All right. What will happen then? This is not there. All right. What will happen? My this function will be skipped because my I is already 1 and F is also 1, right? 1, this will become 1 double equal to 1, which is true. So my this whole will be skipped and my this statement will be executed, right? So my this statement will be executed directly. On execution of this statement, what we have? We will have that head dot next, because my temp was head, right, is equal to head dot next, which means here that if my link was 10, 20, 30, this was my linked list. My temp was here, my head was here. I need to remove the head. But instead of removing the head, what I did was head dot next, which means this was pointing towards this. And my linked list changed to be 10, 30, which is absolutely wrong. This is not the case. I don't need to do this. I needed to do this because I needed to remove the 10. But I instead got this. I got this, but I wanted this. So this was the error. All right. So I did this. What did it do? It returned my head as head dot next. Right. And what is my head dot next? It is 20. Right, guys? In this. So it is 20. So the linked list which was written was this. So that is why I introduced this edge case. So that my proper handling can be done. My f is equal to 1. So covering the whole question, first calculate the size. All right. Second, first we have to calculate the size. Second, what we need to do? Second, on the seconds, in the second step, I would say we need to calculate effect from the front, which is equal to fth is equal to size minus mth plus 1. I am speaking. If you are not able to understand my handwriting, please listen to what I'm saying. All right. Third, I need to traverse and move to f minus 1 net node. All right. Once I move to f minus nth node, first step I need to do is delink from f8 node and link to f plus 1. All right. Simple as that. And the fifth thing is the edge case. Please take care of the edge case. What is the edge case here? If my f is double equal to 1, That is my edge case. That will bring problem to me. So I have to take care of that edge case as well, so that my head is removed, not the middle element like here. So my if my f is double equal to 1, I will just return head dot next. So my head is changed. So my head is removed simply. All right. Also, one thing I told you, which I would like to figure out, I told you like this, it will become null, but I was wrong. Why was I wrong? Because if I see there, this value can never be null. Like this value can never be null because I am going to, this is my fth, this is my f minus 1th. So I'm always going to f minus 1th, right? I'm never going to fth. Suppose my fth was last. Suppose my fth was last. Then also, I am always going to f minus 1th. This was my, like, I have an increase of size 5. This was my fifth node. I have to remove the fifth node. Then I will go to the fourth node only, right? I will never go to the fifth node. I can't remove anything by the fifth node. I will go to the fourth node. So this is my temp. This is my temp dot next. This is my temp dot next dot next. Now this is my last node, so it will point towards null, and this was point towards this. So this value can never be null. So I was wrong. I'm really sorry, but I figured it out, and I wanted to share because I don't want to teach wrong if I'm teaching. All right. So that is what we are like to figure out. So this is the case. All right. This is also I would like to figure out. Come on, man, make a square. All right, finally. All right. So this is the correction that I needed to do. This is why we use the edge case. I told you that. And these are the steps. These are the proper steps that we needed to solve this question. All right. Thank you for watching. Meet you in the next question.